Hi everybody, welcome back on the channel. My name is Kenwad. Well, today the goal of the video is very simple, is to make a quick update before the actual upgrade of Etica v2 and also to give information for future developers that will want to understand how the upgrade system works. So basically, as you can see, it is a two phases system upgrade. So a week ago we made phase 1 and tomorrow it will be the phase 2 that will finalize the upgrade towards Etica v2. So the first phase, what we actually did is that we have upgraded the source code of the blockchain. And for the second stage, what we will do is that we will actually upgrade the smart contract of the blockchain. So right now on Crucible, which is Etica testnet, the system has been upgraded with the process mentioned in this video, in this article. So basically this article, explains in details how we planned, like a year ago to upgrade this Etica smart contract through hard forks, because there are other options. We could have tried to use what we call proxy contracts, for instance, but without getting too much into the details, the downside of the proxy system is that it requires private keys, special private keys, and special rights. So some people have special rights, even if it involves multi-signature system. Some people would have special rights to upgrade Etica smart contract. So this is something we did not want for Etica. So as a consequence, we had to imagine a new system that would require a hard fork in order to upgrade Etica smart contract. And the way and the reason why it was possible for Etica is because Etica has its own blockchain. So basically we have updated the source code, and now we are able to put in place the process to upgrade Etica smart contract. So just to give you quick overview of how it happens in the code, basically so this is Core-Gate, so this is the source code of Etica blockchain, which is a fork of Ethereum Classic. So in the process, in the system, we have, for instance, I can show you, find it. Okay, so in the system, we have something, that, so this is here, so basically, without getting too much into the details, but let me give you an overview of what happens, at the large, scale. So basically, as you can see in the code, anyone can see that there are, these references. So for Etica, this, once we will enter phase 2, this will be, set like this. So basically, this is what happens, is that we have the Etica smart contract address that you can see here. Okay, so this address does not change. It doesn't change. And on Crucible, we have an equivalent. Basically, we have a main smart contract, which is this one that finishes with 82. So this is the main smart contract of the Crucible testnet. And what happens is that when we want to update the bytecode that runs on this address, so on this is what is explained, on this article. Let me find it. Okay, so what is explained on the article is, very simple, well, sorry, so this is it. So what is explained on this article is that on Ethereum there is a separation between the bytecode, which is what runs when we call a smart contract, and the storage, which is like the database, if you want. So there is a clear separation, between these two. And what we can do, you see, so basically we have here, this is what he explained, like we have the storage that is separate from what runs on the address. So basically the bytecode is the code that runs when you call an address. So this is Etica smart contract, for instance. When we call this address, there is a special set of code that runs. It is a smart contract. So when we call this address currently, what runs is Etica v1. The smart contract, so basically it is Etica v1 that runs actually right now when we call this address. But what we can do, thanks to the way Ethereum blockchain is designed, is that we have been able to adapt the system so that now we have a way to upgrade the code here. So here, what we do basically is that we deploy another contract, we deploy HKV2 on the blockchain, and then we take the new address of the deployed contract. And what happens is that this contract has its own bytecode and its own address. But basically the bytecode of a contract never changes. So what we can do is we can imagine a system where basically what we do is what here, as you can see, that at a certain block F, we basically take the address. So basically what this does is that it takes the bytecode that is running on the new deployed smart contract. So for instance here it would be on Crucible, this is the address of the new smart contract. So basically this is the variable that is called here. So we take this address, we take the bytecode from this, and we put it on the address of the current smart contract, the main smart contract. So what this does is that it updates the bytecode of the smart contract without touching at the storage of the smart contract. So this is like the main idea of the process. Then there are additional measures as well, of course. Basically there is a system that adds some information following the block 8, like for 10 blocks, it adds information in the blocks so that any nodes that try to sync with the mainnet, if the node did not go through the stage, to upgrade the smart contract bytecode, basically the node cannot sync, because it will not have the same data, it will not be able to calculate the same hashes, and it will not be able to sync. So basically every node of the network has to go through this phase. And this is the way we upgrade Etica smart contracts. So this way, we could have like cycles. We could basically update Etica smart contract as much as necessary. Every time it's necessary. If, for instance, we find any like bug or any security issue, we have a system, to upgrade the smart contract. And this acts like migrations. Basically anyone that wants to see what happens on Etica blockchain is able to come here to see, okay, so this is the main smart contract. Okay, so for outflow 1, we took this address bytecode and we put it on the smart contract. For phase 3, we took another address contract and we put it on the main smart contract. And basically on the configuration here, we have what we call the block. We have here, we have this variable here. So if I show you on Crucible where it is already deployed, you see, for instance, on Crucible, it was done at this block F, at 703,000, this is what was done. So if now we go on Crucible testnet, we can see that now we are at this block F. So it's been a long time that the smart contract has been updated. And now when we interact with the Crucible smart contract, okay, so this address here, so I am on Remix connected with MetaMask on the Crucible network, 618888. This is Crucible network. So, and this is a main smart contract, Etica smart contract of a Crucible. So basically on this smart contract, so now it is running HKV2, so here, if we call this function, it runs HKV2. So this is the new bytecode. This is the new smart contract. The new smart contract is running with this, so Solidity 8.22. Although the first smart contract, the original Etica bytecode was running, with Solidity 0.5. So yeah, everything has been upgraded, and now we have the quadratic voting system, everything in place. So from a technical point of view, I have to say I think this is absolutely amazing, because right now we have a secure, very efficient way to upgrade Etica smart contract through hard forks, that doesn't require any private keys or anything like this, So for instance, now you see when we call this function, it says, yeah, it is HKV2 that is running, the bytecode from HKV2. So yeah, there are very important things, to take into account when doing this, especially when it comes to the storage. And basically, the new smart contracts have to respect the old storage contract. So basically, we cannot do anything. But don't want to bother you too much with these details. But for any future developers, what you need to truly understand is that when there is the declaration of variables, what is very important is to keep like every variables that has been declared in previous smart contracts must remain, and you can only add new variables, but you have to add them after the previous ones. If you put if you declare a new variable here, for instance, in the middle of other ones, it will basically it will jeopardize the storage of the smart contract because of the way it is calculated. So I had to go very deep into this because but this video is not the goal of this, so I don't want to go too much into the details. So now when it comes to the mainnet, so this is Etica mainnet. This is just a part of the nodes because to appear on this site you need to put special flag in your command line, which most nodes do not do. So this is just a part of the nodes, and as you can see, there are actually a lot of nodes. We can see a lot of peers here, and I would not be surprised if currently Etica has more than 100 or 200 nodes on the whole network. So the Etica network is growing. It keeps growing, and especially also for the addresses on the network. At the space, at the end of the year, we will definitely, I think, pass the 10k addresses threshold. So basically, now about the new Etica v2 system. So this is Crucible network. This is a testnet mining pool I've set, and basically when I need to make tests on the system, what I do is I mine some testnet ETI on this pool, and then I make my tests. So now I want to talk about the new Etica recovery system that we've been talking about, and the fact that it's now available. It will now be available with Etica v2. So now we are on Crucible. This is a local version of Etica.io. Don't pay attention to this. This is just something because it is a local version, but not important. So now with Etica v2, the recovery system, let me explain how it is going to work. So basically, there will be two options to recover lost ETI. So the first option will be if you remember the actual parameters of your vault. And the second option is if you don't remember the parameters of your vault and you just have the commit hash. So, and the two ways are not going to penalize with the same severity and not the same way, because basically when you remember the vote parameters, when you have this information available, the system is able to actually check if you voted on this proposal, and then check if you voted on the right side or the wrong side, and then it's going to basically punish you the same way as if you had revealed your vote on time, but it is going to add a penalty to that. But with the second way, the system has no way to know if the commit was used to vote on which proposal the commit was used to vote on. So the system cannot just add more penalty to what you should have had. So the system is going to, by default, punish the people that use this function with the highest degree possible of the system, to make sure that it doesn't create a new incentive mechanism in the Nash equilibrium, and that it doesn't change the strategies, not create new strategy where people have advantage to use this and to outsmart the system. So basically, when you use the system, it is by default going to apply a penalty, a fee, and it will be the highest possible. But you will be able to retrieve your ETI, but you will have to pay the highest fee possible of the system. But with this one here, it only it is able to find the proposal, to make sure it is the exact proposal you voted on, and then to penalize you accordingly. So let's make just a demonstration of this on Crucible network to finish this video. So basically here you can see on Crucible network we have yeah, this is just a testnet. So basically we can like make new proposals, all of that. And yes, also there is this discussion that we are opening about the future of the protocol. I think it's very important that this kind of decisions is made by the community, because actually this is also what Monero did, and I think this is the best way to do things. So as you can see here, I'm on MetaMask with, so this is testnet eGas, and here I have testnet Ethereum on this account. So now let's make let's make a quick demonstration of this. And also a thing is that since now it's Etica v2 that is running, now it requires 100 bosoms to submit proposals. Okay, so now I have 102, so I can submit one, but with Etica v1 it would just be 10 bosoms, but now it's 100. Okay, so let's take this as an example. Okay, so now do this. Okay, so I'm going to call this proposal I don't know what we were, this one. Yeah, so the system keeps evolving, and this is great. I'm just asking right now ChatGPT to give me an example of IPFS hash. Okay, we're good. And here, yeah, the free field, this is also something that will evolve with time. But basically with this free field, we will be able to put, JSON data for giving more information of what is going on, So again, okay, right now, let me show you what I'm doing. This is absolutely useless, but just to give you an overview, okay, so basically I'm just asking ChatGPT to give me fake information to put just to show you what it could look like. Of course, most of this information will not appear, it will not be used, for instance, for proposal ID, title, all these kind of things, but it will be used for information like organization, which organization is making the proposal, like the authors, we can give a detailed list of the authors, and all these kind of things, so then this information will be used by explorers and things like this, to present the information and the protocol, So now let me just put this here just to show you that this kind of JSON data works. It can actually be put on the protocol, and yeah. Okay, so now I click, okay, I have my MetaMask that asks me to sign the transaction, and I sign the transaction. Okay, so as you can see, now we're on Crucible v2, so it will cost 100 bosoms, to the collateral. It's not a payment, it's a collateral to submit proposals. So now if I go here, if I check this, yeah, you see I have 100 bosoms less, so this is a collateral. So now, yeah, another thing I didn't mention is that on the testnet the periods are much faster. Instead of 7 days, 1 week, it is 2 minutes. So the base duration is different because it's a testnet. It's to enable people to make a lot of tests. So as you can see here, it's only lasts 3 periods. So 3 times 2, it's 6 minutes. So the whole voting system, instead of lasting 3 weeks, here it lasts 6 minutes. So now I'm going to change account, MetaMask, and on this one I've very little to vote and to make the demo. So what I will do, okay, I'm basically now taking my MetaMask to send ETI to the second account. I don't think this involves security issues, so let me actually show you this. It's not complicated. So okay, so I'm going to send ETI to this account. I'm going to send it 100, like again it's testnet ETI. Let's send it 100 ETI and confirm. Okay, so now we are able to use the second account to actually vote. Okay, so on this account you see we have 0 bosoms. So what we will do, we're going to stake 80 ETI. Okay, so we're staking it. And now we're going to vote. Okay, we're going to vote on this. So let's make a vote. Okay, so basically I'm going to vote against the proposal. I'm going to put a vote. Again, if we refresh, we have 80 bosoms available, only 3 minutes to vote. So let's do it quick. So basically I'm going to say okay, I'm going to vote with 50 ETI against. Here for the privacy phrase, I'm going to say test with exclamation point and T upper later. It's very important. It's case sensitive. Okay, if I do this, it's different. The hash is different if I do this. So it's a test with exclamation point, 50 bosoms. Okay, so now I vote. Okay, now the vote is sent. And for the purpose of this video, I'm going to make actually a second vote with this account, and to show you how it would actually work. So let's say someone makes a mistake, and basically the person make a second vote, but this time they use a different privacy phrase. Okay. So this time they use test, but without the exclamation point. Okay, so you can see it's a different hash. So let's send the vote. So it's 2 votes, against, but on with different hashes. Okay, so the system will not enable you to reveal 2 votes. The system will not enable you to reveal 2 votes. I think the second transaction. The second transaction didn't pass because I didn't have enough bosoms. So let me say 20 for the second one. Okay, confirm. My MetaMask told me that the transaction didn't pass because there was an issue, didn't have enough bosoms. Okay, because we had 80, we used 50, and for the second one we tried again with 50, which is not good. So now it passed. Okay, so to summarize what happened, we made 2 votes on 2 different hashes commits. The first one with 50 ETI with test exclamation point as a privacy phrase. The second one as test without exclamation point as privacy phrase. So only 10 bosoms left. So now, up to now, the situation would be like we would have ETI, locked on the voting system, but we would not have a way to recover this ETI because we would not be able to reveal the votes. sometimes people, it's not just they make a mistake, it's they can forget, it happens to people. So up until now, if someone forgot to reveal vote on time, again, we have 1 week to reveal every vote. So yeah, it was a very huge issue on the system, that a lot of people were experiencing, because there was not a way to recover ETI in such situations. So now there is a way. So basically, if so these are the stakes, so right now you can see we have 70 ETI locked in the voting system, and a total of 91 ETI locked, staked. So basically, to summarize, is that we have this stake of 80 ETI we made, and all of this, it was from my previous tests. And on the previous test, I have already unlocked all ETI from the voting system. So basically now we have the 70 ETI from these votes on the voting system. So let's say, that someone, you can see here, there is now a few seconds to reveal votes. So let's say someone forgot to reveal the votes on time, and let's see what happens now. So in order to show you, I have to just wait a few seconds that we reach the end, the deadline, and then I will show you. So first of all, let me show you the interface of this. So the new route to do this would be this. Yeah. So this will be the new route to do this process. So so basically, as mentioned, there are two ways to recover votes. The first one is if someone remembers the parameters of the vote, and the second one is if someone does not. So let's do that. So for the first one, okay, we're going to do that. So I'm going to take the hash of the proposal. Okay, so now, as you can see, the proposal has passed the revealing stage. So now it's too late. I cannot like reveal the vote anymore. So, but the hashes are still in the system. So yeah, let me show you. Okay, so we take this. This is the address of the proposal. So here we put the proposal hash. Then we just have to put the exact same words, this exact same privacy phrase. Then the choice, we chose to disapprove the proposal, and then to check. Okay, so basically, as you can see, it has found the commit. It found it, and it says, okay, there's 50 ETI here. This is a timestamp, and it tells me that it cannot be recovered yet because the proposal has not entered the claiming stage. So after the revealing stage, the proposal is only claimable when the whole period of the proposal finish and reaches its end. Okay, so right now we still have to wait a little for this proposal in order to do this. But what I can show you in the meanwhile is this. So this is the commit we found for this proposal. What did I do? Okay. Okay. I hope it didn't stop the sound. But okay, so basically now let's so this is like the first commit, but I want to show you the second one as well. Okay, and by the way, this kind of videos, like this starts to be like some most advanced level for Etica, and I'm going to make others video like this in coming days or weeks, because yeah, I think that right now there is a very high part of the community that truly understands the economic system of Etica very well, and yeah, this is like the elite of this community, and basically that at some point I will just be one of the members of the community, and every like changes and every upgrade system, that would be possible. I think other people could have also other ideas, how we can evolve this system. But yeah, I think yeah, once I just show you this, I think I will not end this video right away. I will maybe talk very quick about the what we've done so far, and what we will do in the future, because I believe that yeah, this is absolutely amazing. But yeah, let's finish this demonstration very quick. So basically, so yeah, so this is a commit here, and if we want to do the same for the other commit, let me show. So yeah, take this, put the proposal hash here. The second one was this, but there was no exclamation point. So okay, so for this one it tells me I didn't find it. Okay, let me see what happens. So yeah, so this is not a good route. Okay, let me see what happens with this. Okay, so we say this, we take the good proposal hash. Okay, privacy phrase, it was this, it was disapprove. Okay, that's strange. Okay, there is always an explanation, so we'll find it. Just a question of okay, so maybe I use a different privacy phrase. Oh, you can see, this is how it works. Basically this system, we have the possibility to search, the possibility, yeah, like as a Etica user, basically you have all the systems, that enables you to search. I think I know what happened. Certainly for the second test, when I did it in a kind of a hurry, certainly I didn't put the privacy phrase. And I'm sure if I check the video, this is what we'll see. Yeah, you see, there is no bug in the system. It's always, a question of yeah, so yeah, so this is what happened. Basically I forgot to put the privacy phrase on the second one, and I'm sure if in the video you get back, you refresh, you get back on the timestamp, you check what I did, you will see that on the second time I didn't put the test. I was in a hurry, and I was like, okay, and I forgot to put test. So this is what happened. So now my second commit is here. Now let me show you how it's possible to yeah, to recover the commit. So as a summary, basically right now we are someone that voted. Basically first we made a mistake because we voted twice on the same proposal, and it's not possible to reveal two votes on the same proposal. So basically there would be no way for us to reveal the two votes, so we would be forced to use the system anyway. But not only this, but we basically forgot to reveal any vote on time. Now the proposal time is passed, so we are forced to use the system. So now I will show you how it's possible to use the system with both functions. So for the first time, let's say we remember what we used, Okay, so for the first time we remember. Okay, we remember that for this one we used the password, the privacy phrase test with exclamation point. So now I'm going to do this, and I'm going to add the exclamation point here. And yes, it's a disapproval. So let's do this. Okay, now you see it's possible to recover. We have passed the the proposal has passed the stage. So with this, you know, it will be like very, let's say to some extent, intelligent recovery system, because it will identify the actual proposal of the vote, and it will put the same like penalties, but with additional penalties, as if it was revealed on time. This is what it will do. So let me show you. So this is the current stake system, you know, of this address, and you will see that when we will apply this, it will have impacts. Okay, so for this one, I don't think it will imply a fee. It will only apply additional stakes, you know, and extended stakes. So right now you can see that there is this one of two of that ends 20 February. Okay, this one 13th February, but you will see that it will change, you know, the system will change after we do this. So now let's say, okay, so we forgot to reveal and we want to unlock ETI from the voting system. You can see that right now we have 70 ETI locked, and thanks to this we will be able to unlock ETI from the voting system. Okay, so let's do this. Okay, I clicked here. Now I can sign the transaction. Okay, I'm signing the transaction. Now it's sending this transaction. Again, now it's Etica v2 that is running on the Crucible main Etica smart contract. So it used to be Etica v1, you know, where search for features functionality did not exist. But now, thanks to the whole upgrade system of the protocol, it's possible to send this transaction. It will be accepted by all nodes of the network. Okay, now it has been confirmed. So if I go back here, you know, so this is it. I'm going to put it, you know, on the second tab to compare. Okay. Okay, so as you can see now, the stack system has changed. So right now you can see that it used to be like the max time used to be like 20th. Now, first of all, it's the 27th. Okay, but beyond this, you know, you can also see that now we have only 20 ETI locked in the voting system. Right here, only 20 ETI, although we used to have 70 ETI locked here. And now also, you know, you can see itself. So if we actually compare, you know, like what happened on the two, you know, two phases of this, because for this one, you know, it basically just took what would have happened and it added some additional penalty. So it is, you know, severe, but it's not as severe as if you use the second one, the second option that I will show you just after this, you know. So basically, if we take this and we compare, so this is an after calling the function, and this was before. So before we used to have 70 ETI locked in voting system. Now okay, so now we have 20 ETI locked. Yeah, I clicked on the button. Now I don't know how to collapse this back, but I will show you like this. Okay, so yeah, we'll show you like this. So now when it comes to, damn, why it doesn't want to go back. Okay, at least we can see. Okay, great. So now let's compare. So first of all, we can see that this stake has been extended from 20 to 27. And I remember that on this, okay, 2 minutes is the period. So basically, like from 20 to 27, it will not be like a week. It will be a lot more, much more time, you know. So yeah, so this stake has been extended. Then this one. So here we have 6 stakes. Here we have 5. And yeah, let's see the differences. So basically, this one also has been extended. You can see sometimes what had it, you know, it's the same amount, but look at the time, you know, it used to be like this. Here a whole like 7 days has been added. But again, like the basis is not 7 days here. The basis is 2 minutes, so it would be like a lot much more time than 7 days. Here as well, you can see stake 3. It used to be 13th February, now it's 20th February, so a lot more duration. Stake 4, now it's 13, it used to be 6. And now you can see that here, yeah, the last one, it's 13 as well, and it used to be 6. But you can see that there is a part of the stake, like for the last one, it's the system has split. The system split. It's split. You see, the last one is split the last stake into 2 stakes because it applied the penalties only on the vote amount, and the vote amount was 50 ETI. So it did not apply on the whole stakes. It only applied on the 50 worth ETI. And once the system found that it reached 51 ETI, it split. And the last one, it let it as such. So if we compare the last one here, I don't know if you like see the complexity of the system that is completely running autonomously on chain. Like, look, for this last one, you see the amount, it used to be 80, now it's this amount, it's split, and this last one remained the same one. Okay, so now we've been able to unlock ETI from the voting system using this function, and as you can see, it adds additional penalties, so no one has interest to purposely not reveal a vote and to use the system. And as you can see on this case, it did not apply a fee because it was able to identify the proposal. It was able to see that this vote was not like an extreme vote that voted on something that the whole protocol, like massively rejected, and that this vote was not subject to a potential fee. So it did not apply a fee, but instead it only has added additional slashes to the slash that this vote should have had. This is what it did. So now let's basically do the last one. The last one. Okay, so I had some windows opened for this, but yes, this is it. So let's do the last one. So for the last one, so what we did here is this, okay? We have revealed this one. So now if we call back this function, we will not see it again. The 50 ETI, we will not see it again. Let's do this. I'm just going to show you very quick. So what we did here is we did this. Then we put the proposal hash. Okay. Whoa. Okay, I have to refresh. Let's refresh. So yes. So basically we put the proposal hash here. Then we set the privacy phrase. It was this one, I think. And now you see the commit has disappeared because it was unlocked by the system we did. Okay, when we called the function, it disappeared. So no one can like reuse it, to reprocess the transaction. It disappeared. So now let's do the same thing for the second one. So for the second one, as a reminder, so basically for the second one, what we did is we did this. Recover. Let's say someone wants to find it. You just have to do this. You remember that you did not use privacy phrase. You do this. Okay, now you found it. So this is the second one. So now we are able, from this, to take the proposal hash. Okay, so let's take the proposal hash. Now we go on the revealing page. So the revealing page is going to be this one. Okay. Okay, so now this is a revealing page, and this time, we say, okay, for this one, we forgot the privacy phrase. We forgot that we did not use a privacy phrase. Okay, So we are unable to do this. We're unable to do the same process as we did before. The same process as we did before would be to put the proposal here and then do this, and then we would be able to do exactly what we did here. So we cover without any fee. But because we forgot the privacy phrase, we cannot do this. So I'm closing this, and here we can't do this because we don't remember this. So what we do instead, we call the second function, and this one is like the one you never want to call it, because you are sure to get the highest like severity penalty possible, because like this is a last resort system, because again the system cannot know exactly the proposal you voted on, and if like your vote would have been subjected to the highest fee possible, it doesn't know this. So by default it will apply the highest thing possible, and even higher than the highest thing possible, so that the Nash equilibrium of the system is not jeopardized, and that no one tries to outsmart the system. So now, yeah, you basically don't remember this. So, but what happens is that when you vote, you can still get the commit hash, and for this, I will just have a system, but this is like another thing, is that to get this information of the commit hash, what will be possible is that since every vote is on chain, it means that for every address we have the history of the hashes of the commit. So it will be possible to write just a quick script that for the connected address is going to check on the blockchain the commit hashes and identify the commit hashes that still have a vote active on it, and basically then present them to the voter, and tell them, okay, so this commit hash corresponds to so basically this commit hash, we don't know which proposal it corresponds to, but we know there is this amount of HI. Do you want to retrieve it or not? And also, from a commit hash, let me show you this very quick, that there is this page, that you can use to check how much there is on the hash. So basically, there will be a script that will propose for every address the commit hash is active, and when you call it, okay, you can see, not only you can see the amount, but you can see the timestamp. So even if you don't remember for which proposal it was done, you can see the timestamp. And for instance, if you see that this is a very old timestamp and there is no way there is still a proposal active for this, you can be sure that you want to recover this. But since you don't remember the password, the privacy phrase, then you are forced to use this function. So there will be like this system. So now let's recover this. And again, before we do this, let's actually do this. Before we do this, let's also open another tab with the current stake system of this address. Okay, so this is the current stake system of this address. We're going to call this function, and then we're going to compare last time. And again, right now you can see we have a total of 91 ETI stakes, and we have this amount of blocked. Okay, so now what we expect is that this time it will actually decrease the total value of ETI stakes. It will not just extend. The first time, we have seen that it only extended the times. Okay, it only extended. But this time, because we will have the highest fee possible of the system, what we expect is that it will not only extend the times, but it will also decrease the total value of ETI staked on this address. So basically this will be the fee. So let's do this. Okay, so I'm going to call the function. So now it found my stake. I confirm. Okay, I open MetaMask. I confirm MetaMask. Okay, now it's confirmed. So let's open a second tab and compare. Okay, perfect. So now we'll be able to compare what happened. Okay. So this is the which one is it? This is the first tab. Okay, this is the second tab, the new one. Okay, so now we can compare. So first of all, you can see that on the second one, now we have less stakes than we used to have. We used to have 6 stakes on this address, now we have only 4 stakes. Second thing we can see is, let's see the total amount. So as you can see, the total amount, again, only 20 ETI was punished, okay? So from the 20, so the old value was 91 ETI, 92, 91.8 ETI on the system. But now we have 85.8 on the system. And okay, let me refresh this. And now let's see this, you know. Let's see this. So now instead of let me see this. Yeah, so basically here we used to have 6 stakes, now we have only 4. And we can also see that yeah, only the stakes of the 13th remained, and that, so basically this one, you know, since the value was very low, it was included in the fee, so they disappeared. This is what happened. And now, yeah, we have this fee applied, and this also, you know, this amount was decreased. So yeah, you see that the system was updated with a fee and with yeah, a kind of extent, you know, of the voting duration. So yeah, I mean, this system is pretty complex, you know, it's pretty complex. And to actually, you know, see in details what happens, you know, it will create a deep analysis, you know, that will take a lot of time, so I cannot do this right now. But as you can see, you know, basically the fee was applied and the number of stakes was decreased, you know, because we used like the hardest function. And again, like, it's about like from 92 to I mean 91 to 20 to 85, it's about like 6 out of 20. So yeah, you can see that it's a huge percentage of the ETI that was that got a fee, you know. So now, as you can see, you know, the blocked ETI, I think this is a UI. I don't know why it does this, you know, we cannot see like now the blocked ETI should be 0, you know, after this, you know. So, but yeah, as you can see, you know, the sim was done. Now let's take the address, it's this one, okay. So if I take this address and I go, for instance, here on Wemix, and I go on bosoms, yeah, I'll see bosoms here, no, just check this works. So put this address, and yeah, you know, so this is what is left, you know, in the bottoms, you know. So yeah, this is not what I was wanting to check, is the ETI locked, ETI locked, ETI, so yeah, now this one, what is it? Yes, blocked ETI. So this is, I'll check. So you can see it's 0, you know, now it's 0. But before this it was like 20 ETI locked, now it's 0. So basically the function worked, you know. Everything is working as planned. So yeah, so this was like a demonstration, you know, of the system, how it works and how it's possible to recover lost ETI. So now yeah, so basically yeah, this this, could seem like a little upgrade or little thing, but actually for Etica this is a huge thing. This article was, I didn't even notice this is absolutely crazy. This article was written exactly 1 year ago. I mean, tomorrow will be February 7th, and it will be the date of the Etica hard fork. So basically, exactly 1 year later after this article, we will actually put this into action. It has now been tested on Crucible network for several, days, and everything is working as expected, and to actually, go from just a simple, idea of how we could upgrade the Etica smart contract to the actual implementation and to have this put in live on the mainnet of Etica blockchain. This is absolutely huge for the project, and this is like a very important news, because when the blockchain was started and that we decided to use Etica blockchain with its own mainnet, one of the most important question was, okay, there is of course the question of security, all of this, but there is also the question of how is it possible to upgrade Etica smart contract. If you basically say that the main system relies on one main smart contract, and that the blockchain is dedicated to this smart contract, what happens when you need to upgrade the smart contract? And basically, within the changes that are coming with the smart contract upgrade, there is this like slight security upgrade when it comes to a potential mining potential mining pause possible if someone makes a very specific transaction. But this was removed with Etica v2, and yeah, this is, let me show you. So the fact that we have the possibility now to upgrade Etica smart contract and to basically update it not only once but as many times as possible, and with almost any degree of flexibility necessary. Now we understand how the storage system works. Yeah, I mean, this is like one of the most important challenges of Etica when it comes to technically that is about to be overcome. So in my mind, what we've done so far is absolutely amazing. Let's keep going. So basically, the how can I say it? If we take what we've done so far, like the first year, 2022 was like focused on mining aspect, launching the mining pools, launching the miners, all of this, and it was a very important year for Etica. The second year, 2023, has been like a consolidating year with much more people coming in, and the research that has been started, this research, now we're still at the very beginning of this, but if you go on etica.io, you check the research and the research activity, and also the number of people that truly understand the protocol and how it works. This is absolutely amazing. So in my mind, what we've done so far, it's like we went from 0 to 1. Like we have like not only the prototype, but we have been able to use the blockchain for its true use case. So actual research has been funded in a neutral, censorship resistant way, and now it will just become a question of how we can actually scale it. But we have to some extent gone from 0 to 1, and this is absolutely amazing. If you go on Reddit, you can see the history of Etica. It was started in April 2022, so it's almost 2 years ago. And when you see what we've done so far and how the project has been growing so far, I think this is absolutely amazing. And to some extent, we went from 0 to 1. But now it's the next stage of the project. It's about getting to the next level. And to some extent, getting from 0 to 1 can be harder from what is coming, but I think we are going to keep growing as a community, and to potentially one day become one of the biggest cryptocurrencies. And reason also of this video is that I want to start, I want this year to be a year where basically I will give as much information as possible, so that also as well developers can join Etica and start building on top of Etica. Because the thing is that so far, we've been like shaping the protocol from like the current community. We start to grow, but we're still relatively small community with a few thousand members. But one day, we could basically become one of the major cryptocurrencies. And for this to happen, of course, like I cannot like be the only developer. We need an ecosystem of developers. There have been also new developers coming in. Dev to mine, dev to live, on Discord, has been doing great, amazing things. Like here, the Crucible network, all of this, and now we need to go to the next level. So a part of this, is to have an ecosystem of developers, and I will give the necessary information so that we can start to get as much developers as possible and as much applications built on top of Etica, and with Etica, as much as possible. So yes, that was just a quick overview of what the Etica v2 is going to look like, and the kind of work that was done to put this in place. And yeah, I will come back with other videos. This was just kind of update of the situation, and yeah, thanks for watching and have a great day.